Ever watched ice slowly melt into a puddle of water? Or seen boiling water transform into steam rising from a kettle? What about camphor disappearing into thin air without a drop left behind? These aren't just interesting visuals, they're everyday examples of a powerful scientific truth: matter can change from one state to another. But what triggers this change? Is it heat, pressure, or something more? In this video, let's uncover the fascinating science of how and why matter changes its state, starting with the world you see around you. Let's start with the most common factor that changes the state of matter: temperature. When you heat a solid like ice, its particles begin to absorb energy. This energy makes them vibrate faster until they can break free from their fixed positions. That's when melting happens. The exact temperature at which a solid turns into a liquid is called its melting point. For ice, this point is 0 degrees Celsius or 273 Kelvin. Try this activity: place some ice in a beaker, insert a thermometer, and begin heating. You'll notice something interesting. The temperature stays constant at 273 Kelvin while the ice melts. Why? Because the heat energy isn't raising the temperature, it's being used to break the bonds between the solid particles. This hidden heat is called the latent heat of fusion, the energy required to convert 1 kilogram of a solid into a liquid without a temperature change. Now, continue heating the liquid water. As it reaches its boiling point, 100 degrees Celsius or 373 Kelvin, it begins to vaporize. And again, the temperature doesn't rise during the change. Why? Because the heat now goes into overcoming the attraction between liquid particles to turn them into gas. This energy is called the latent heat of vaporization, the amount of heat required to convert 1 kilogram of a liquid into gas at its boiling point without a temperature change. Now that we've understood the concept of latent heat, let's apply it with a quick numerical example. Question: how much heat is needed to convert 2 kilograms of water at 100 degrees Celsius into steam without changing its temperature? Given, latent heat of vaporization of water is 22.5 times 10 to the power 5 joules per kilogram. Step 1. Use the formula: heat equals to mass into latent heat. Step 2. Plug in the values. Heat is 2 times 22.5 into 10 to the power 5 equals to 4.5 into 10 to the power 6 joules. That's 4.5 million joules of energy just to change water into steam at the same temperature. This highlights how a huge amount of energy is hidden during a change of state, even though the temperature stays exactly the same. Here's something fascinating. Did you know that some substances skip the liquid phase entirely? This process is called sublimation, where a solid changes directly into gas without ever becoming a liquid. You've probably seen this in action with camphor, dry ice, or even naphthalene balls. They seem to vanish over time, but in reality, they're turning straight into vapor. Try this simple activity. Place some camphor in a dish and cover it with an inverted funnel. As you gently heat it, you'll see vapor forming directly from the solid, no liquid in between. Sublimation isn't just a cool trick, it's used in air fresheners, dry ice cooling, and even in certain purification techniques. Think temperature is the only way to change the state of matter? Let's add another factor to the mix: pressure. When you increase pressure and lower the temperature, something fascinating happens. You can force a gas to become a liquid. That's exactly how LPG cylinders and oxygen tanks work. They store gases in a highly compressed liquid form, making them easy to transport and use. And here's another cool example: dry ice or solid carbon dioxide. It's formed by compressing coal gas under high pressure. But as soon as you release the pressure, it skips the liquid phase and turns directly into gas. That's sublimation in action, again. So remember, by simply adjusting temperature and pressure, we can control how matter behaves and what state it takes. Now that we've explored how matter changes its state, let's bring it all together with a simple concept map. Melting, solid turns into liquid. Freezing, liquid turns back into solid. Boiling or vaporization, liquid becomes gas. Condensation, gas cools down into liquid. Sublimation, solid changes directly into gas, and vice versa. And these aren't just textbook ideas, they're all around us. When water freezes, it forms ice. Boiling water gives off steam. Steam cooling on a cold surface turns back into water, that's condensation. Dry ice, it sublimates, changing from solid core straight into gas to keep things cold. These changes power weather patterns, household appliances, and industrial processes. From your kitchen to the atmosphere, matter is changing its state all the time. Let's take a moment to recap what we've learned about how matter changes its state. Heat energy affects how fast particles move, that's their kinetic energy. Latent heat helps matter change state without raising temperature. Pressure can also control the spacing and movement of particles. And sublimation is that unique shortcut straight from solid to gas. So why does matter change its state? Because its particles either gain or lose energy through heat or pressure. Simple, yet powerful. And up next, we'll uncover a process you feel every day, evaporation, and the secret behind why it actually cools things down. Don't miss it, it's going to be refreshing.